So let's go through this. So we got to start at the top here. We want to start where that circle is because we got to start with the sun. If we're going to talk about energy of the earth, then we have to start with the sun because the sun is what gives us all of our energy. Okay? If we have no sun, we have no energy. So we got to start there. If we want to look at how the planet heats up, then we got to look at there. But if we're going to look at how that energy goes through our atmosphere, then we need to do a quick recap on the structure of the atmosphere. So follow the arrows, you go over to the right. And I apologize if these are a little bit blurry. When I made this, I should have used a different, when I saved it as a PDF. And the PDF doesn't actually expand and contract when I zoom into things. So one of the problems is that it goes out to be a little bit blurry. There's other things I should have done that actually allows it to do it. So if you can read it, you should be able to read it. It should be fine. So we start out with the atmosphere. What's the next one down? What do you think? What do you think? What do you think? Take a guess. Pizza. Okay, good. Yes, no. It's the structure. So we're going to look at the structure and how everything is layered out in the atmosphere. So we're going to go from outer space down to the surface. So we'll start out here at... Yep, very good. So the first one is we got to start out of space, right? So here we are, we're out in space and we're falling back down to the surface of the Earth. So what's the next layer that we'd go into? Space, and then start with the E. Exosphere, good. So we're going to go down to the exosphere. And this line right here, if you remember, that represents temperature. So if we were going out, it would get warmer as we go up to space. But if we're going in, it actually gets cooler as we start entering into our atmosphere. Next one, thermosphere, right? Okay, and by the way, in the exosphere, what do we find out there? Yeah, we find satellites, we find spacecraft, we find the International Space Station, all of that stuff. When we get down here into the thermosphere, we're going to find the aurora borealis. Okay, this is a highly electrified region. It's also known as the ionosphere, but we're not going to put that in here. So it's cooling down, and then we get right here, and it starts to, it starts to stabilize a little bit. And we get through that pause right up and through here, and that is known as the mesopause. And then when we get in the mesosphere, what happens to the temperatures? We start to drop close. Yeah, it starts to increase. If we go the other way, it would cool down, but this way it starts to warm up again, which makes a lot of sense, because if objects were to fall in from space, when it hits the mesosphere, guess what happens to those objects? They start heating up and they start burning up. So it makes sense that this is where we're going to see like meteorites, falling stars, all that takes place in the mesosphere. We also have those little lightning things called sprites that actually shoot upward and downward at the same time, and they take place in the mesosphere. Some of those we believe that they actually are caused by radiation from the sun that triggers those. It's kind of cool. But we don't know much more than that about the mesosphere, just simply because this is a hard place for us to get to and actually do some research. What's the next one down? Starts with a S. Stratosphere. Yeah, you know the ride down in Vegas? That stratosphere. So we go down into the stratosphere. Good. The stratosphere is really interesting because this is the first layer. As you start going up, it starts to warm up. But coming down, it starts to actually cool down. What do we find in the stratosphere? Yeah, we have no weather in the stratosphere. We fly commercial planes in the lower part of the stratosphere. We also find the ozone, which is partly why this warms up, because the ozone layer actually traps that heat and blocks that stuff out. And we end up with a warmer upper portion of the stratosphere, but a cooler portion of the stratosphere. Next one down. It's the one that we live in. It is the troposphere. Good. So the troposphere, this is where we find all of the weather. So all that weather you see, all the water's trapped here. This is the one that we walk in and we live in. This layer up here is called the tropopause. That's where the temperature changes. And if we go from the surface up, things start to cool down. We get up here around negative 40 degrees Celsius or Fahrenheit. It doesn't matter, it's the same temperature. But we definitely get some pretty cold temperatures up there. Super cold. We don't really want to be up there without protection. You'll get frostbite super fast. Okay. Well, negative 40, that's pretty cold. What's next? Let's go back up to the top where that little circle is. So let's take a look at that ultraviolet energy that's coming in. And 100% comes in, but it's going to go down through all those layers, and something's going to happen to it. Yeah. It's right here. Yep, you got it. 100% of that ultraviolet radiation enters in from the sun. It's going to go down through those layers and what's that? Yeah, perfect. So it hits the ozone layer in the stratosphere. And then follow the lines. Yep, that's the ozone layer. And how much of that energy makes it through? 5%. Good. So if we go through that and go down, or I think it's off to the, it goes down and off to the side. Maybe. Dun, dun, dun. There we go. 5% of the Earth's, 5% of that UV makes it down to the Earth's surface. So it's down there, making things nice and warm. Thank goodness it's only 5%. We don't want more than that, but we don't want less. More would make this a really hot place. Less would make it a really cold place. So we like that 5%. That is normal for us. Okay. Sure. You put in what you feel like it's going to make sense. Okay, now let's go down to the troposphere. You notice, yep, I've got another little bubble down there. Do we find ozone in the troposphere? Yeah, we do. We do find tropospheric ozone down here, but guess what it is? It's a pollution. We don't like it. We don't like it up close to us. We don't like to be around it because what does it do for us? It makes us sick. It makes us nauseous. It doesn't feel good. You guys have smelled ozone before. I'm more than positive you have. Sometimes after a lightning storm, you can smell ozone in the air. If you've had lots of lightning, if you plug in something into the wall and plug it really fast, you get a little bit of a spark. There's a smell that goes with it. That's ozone. If you've ever used like a blow dryer or a drill and put it underneath some stress, it makes a funny smell. That's ozone. Okay, and that smell kind of makes you a little nauseous. Computers produce ozone. But a lot of things, especially if they have electric motors and they're put under stress, they'll produce ozone. Okay. Anytime you can get a spark or anything like that, it will take the oxygen in the air and transform it into ozone, and you can smell it. Okay. Yeah, it for you, it doesn't make you feel very good. It kind of makes you a little nauseous and sick for sure. So tropospheric ozone is not good for us. It's pollution, but when it's far away from us, we like it because it does this. Blocks out 95% of that ultraviolet radiation, which is a good thing for us. Can you imagine if there was less blocked?
Without that ozone layer, we'd all be dead.
We'd be crispy critters, right? We'd all be like pieces of bacon walking around the surface of the earth. It's like, bacon. We'd have dogs following us everywhere. Bacon, 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 right? Be horrible.